Hello everybody, in today's lesson we're going to be talking about how to find inflection points and concavity. So inflection points and concavity. So first of all, we're going to give a bit of definitions on what inflection points and concavity are. So inflection point is essentially where you can say curvature of graph changes. So right here, you know that the direction of the line changes. So in the clear example, we could do something like that. So we see from the left hand side, the graph is going down, but then from after that inflection point, when you go to the right, it curves back up. So that is an inflection point. So it's basically where curvature changes. And now speaking of curvature changes, we know that at a curvature change, there will be a concavity. So a concavity is essentially something like that, where what direction something is facing. So this will be concavity up, concavity down, really simple. So if we have a graph again like this shape, we know that this from to the inflection point from the left it will be negative concavity, and to the right it will be positive concavity. Now if you have noticed, positive concavity it faces up and negative concavity faces down. So now with this definitions out of the way, we can start doing a problem that will enhance our ability to comprehend what inflection points and concavity are. So pretend we have a question like a function y equals x cubed 3 times x cubed, let's say, plus x. And you want to find the inflection points and concavity of this function. So what we do first is that we take the derivative of it. So y prime is equivalent to 3 times 3x 3 minus 1 plus 1 times x 1 minus 1, just power rule. So that would be 9x squared plus 1. Now we take the derivative of that again, which will be 18x. Now we know that double derivative will help us find inflection points because that's the definition of it. So we let y prime be equal to 0 because when there's an inflection point, the tangent line's slope will be 0. So 0 is equivalent to 18x. That means x is 0. Now we can plug x equals 0 back into its original function to find the inflection point's coordinate. And that will be 0. So the inflection point will be 0, 0. Now, to find concavity will be easier. Now you have the inflection point. Please note that in the graph there could be multiple inflection points, but for my example there is only one. So with this inflection point, you just have to set some values for it. So you could do an XY chart. So when it's 0, so you have to put in coordinates at both sides of the x value. So -1 and 1 are by 0. So when it's -1, you know it's approaching from the left, and then when it's 1, it's right side. So when it's -1, you could plug it in to f double prime of x, which is the double derivative of it, which will be -18. That will be 0, and then that will be +18, since you just plug the x value into the double derivative. Now, what this does is essentially shows you the concavity, because now we know that, let's say, xy coordinates here, 0, 0 is a concavity, and when it's -1, since the function is negative, we know that there's a concavity facing down, somewhere like that. And since when it's on the right, it's positive, we know there's a concavity facing up. So the graph will look something like that. And then you'll go down, and this one will go up. So we know that from now we can write the points of concavity out when it's from 0 to positive infinity. Since there isn't a defined range for our question, that will be concave up. And then when it's from 0 to negative infinity, that will be concave down. Again, since there isn't a range defined. If my original question, let me scroll up, was, let's say, in the ranges of -5 and 5, it would be just in the confines of that. That is essentially how we find concavity and inflection points. And I hope you enjoyed this lesson and found it helpful. I try to keep it as short and concise as possible.